Hello everyone, my name is Hans Dockter. I'm the founder and CEO of Gradle. And with me is Sam Snyder, an old friend of the Gradle project, a senior software engineer from Tableau. And I'm very excited about this presentation. What Tableau is doing with data analytics around developer productivity. I haven't seen any organization in the world that is close to what they are doing, right? So I think you can learn a lot from what benefits you get if you take developer productivity and the data around that seriously, right? And use it really for prioritization and actionable things, right? So welcome Sam, thanks.
Good to be here, Hans. Thank you very much to you and the rest of the Gradle team for having me. I've worked at Tableau Software for about 4 years, and I've spent about the last 2 of those years focused on delivering the best developer experience I possibly can for my peer developers at Tableau. And so in this presentation, I'll go over some of the things we've learned and how you can apply those same lessons to your development organization, combining the power of Tableau's tools for visual analytics and Gradle Enterprise's detailed collection of build telemetry. So first, we're going to establish a little more context, and I will walk you through our journey through time and our journey through data analysis as we came to build happiness. And I'll share some challenges that we encountered along the way and lessons we learned and strategies to mitigate those challenges. There'll finally be a very brief how-to guide at the end and a question and answer session, but you can of course ask questions all throughout the presentation. Yep. And Hans will find a suitable point to interrupt and let me know. Context. So Tableau Software, for those of you who might not be familiar, make data analysis and visualization tools. It's a bit of a cultural thing that we tend to shorten data visualization to viz a lot when we talk. It comes up a lot when you make data visualization software, so having a shortened term there is useful. Technically, as a development organization, Tableau Desktop is probably the majority of the code, and it is substantially C++ based with some web components in the UI. And there's a little bit of Gradle orchestration here, an increasing amount, but the primary usage of Gradle at Tableau is in building Tableau Server, which is substantially a Java product. And Tableau Server is where I came from. I was a product developer working on features and testing for the Tableau Server project. And me and my peers were frustrated with how bad the developer experience was. At this point in time, 2 years ago or so, our build wasn't Gradleified yet. It was a mixture of Ant and Ivy and homegrown scripts that orchestrated Ant and Ivy because writing all of that XML format was just too much of a pain. So, in order to help my friends and in order to help myself have a more fun and productive day, set out with some other interested coworkers to migrate our build to Gradle. That immediately delivered some great gains in terms of performance, in terms of extensibility, but it was only the first step, right? We had a build with some deep problems, and we accurately modeled a build with deep problems in a different tool. And so it continued to accurately model, substantial problems. And so those of us who came to this project came to it from a background of software engineering, right? We were product developers first and build guys accidentally, I would say. And so in terms of how to advance the state of this build, or how to achieve developer productivity, we decided that the strategy that resonated the most with us would be to treat the build like software. Because, it is software, right? If you have an Ant and Ivy build or a Maven build or any other kind of build with a kind of document format that specifies your build logic, you might be able to pretend that it isn't software because you're writing XML, it's ostensibly a document. But if you look at it from any other angle, it really comes away looking like software with all of the burdens that software has, all of the weight of complexity. And if you want to manage that complexity, the discipline of the software engineer is the way to go, to do the testing, to do the static analysis. And key, for purposes of this presentation, to gather telemetry and metrics, analyze them, and make database decisions about the areas that are most important. So that was ended up being a key factor in why Gradle as a build tool was able to be useful to us, is that we could gather this telemetry, establish those metrics, and optimize them over time. Our journey to build happiness is ongoing. It is a kind of pursuit that the value is in the chase, is in the work you do to seek the aspiration, even if you never fully achieve it or never permanently achieve a perfect state of build happiness. Because those pesky developers are going to keep on adding new code and changing things despite your best efforts. The very first most important thing in terms of developer happiness is at least as it relates to the build, is the error rate of the build. If the build fails, if it falls over on itself, if it spits out cryptic problems that they can't reason about, just completely throws them off and sends them down to some unrelated rabbit hole. So our very first priority in terms of using Gradle Enterprise Telemetry with Tableau was to figure out what issues are the most important, as when there are dozens of issues and many people crying out for help, it's not always clear what the most important issue is, right? I mean, if Joe developer's build is down and he can't get his work done, that's a terrible crisis for him personally. But if everyone has problems to varying degrees, maybe he's the only one experiencing that particular problem, and you're going to get a lot more value out of figuring out what issues affect the most developers the most often with the greatest severity and least ability to mitigate. So one of the vises that we have made that has been the most useful to us in terms of advancing the state of developer productivity has been this data visualization that analyzes local failures. All right, so there's a lot of colors going on here. So just to explain what we're looking at right now, the left side is a temporal view of all of the problems that have come up on developer machines in Tableau over the past several months. They were ostensibly synced to a state of the build, a state of the enlistment that should be green, and some local condition or some flakiness in the test or flakiness in the product or flakiness in our build caused them to fail. And on the right, we have a spatial view of the same information. And so what we have used this to do very successfully is identify what the most serious problem is. It's going to be in this upper left corner, the biggest problem that affects the most people, and then fix that, and that goes away. And then you recursively pop off and go to the next problem, and the next problem, and the next problem, which over time leads you to a much better state than when you started. So,
One quick question.
Of course.
How did you measure no open files? How did you filter for that?
Excellent question. Here we go. So we use Gradle Enterprises in the build scans custom values feature in order to record the version control system, as we use both perforce and git in various places, the change list number or the origin commit hash in order to provide context. So if someone's build is broken, you can easily compare that to any known issues that might be going on at the time. And how many files they had open for edit, or how the state of their branch differed from master.
Cool.
And so using this information, it really helped us to cut through a lot of the noise about, if compile Java fails and they forgot a semicolon, it should have failed. So
Yes.
this is to try and identify only those task failures
Right.
that should not be
Yeah.
the developer's
Wow.
fault.
Nice.
Oh, and while we're here, you can dig into the test information and see that, and if you go through a few more scans, this one particular test happens to be the one that accounts for every single one of these failures, right? So that wasn't a hard fix, right? It was only a couple lines worth of change in order to make this very substantial pain point just go away. But as you can see, this doesn't happen to everyone all the time, every day. There's a few instances per day of this now. And so we probably wouldn't even been able to tell without Gradle Enterprise that this was the biggest problem, right? Every time a test, particularly with flaky tests, if it fails once, the developer runs the build again and it passes, they probably grumble a little bit, but don't actually reach out to anyone to be like, this needs to be fixed now.
Yeah.
So this can cause pain that normal channels of communication aren't going to clue you in on, or aren't going to clue you on with enough specificity to really identify and fix that. And one nice little detail is that these views complement each other really well. So the spatial side, shows things from all time, and so you might conclude that clean is a big issue, that for some reason clean fails. But if we look, all of the issues with clean were clustered on this one day. And in fact, it was one developer who had a local issue with a service holding open handles on files so that the Gradle clean test could not delete them, which points to one of the perils or pitfalls of this kind of analysis. In our pursuit of clean data to work with that was as free of noise as possible, we made ourselves a little bit susceptible to one person or a small number of people doing a lot of builds and amplifying the signal of a relatively minor failure. So in this case, there is no substitute for expertise, for domain knowledge of the build, for domain knowledge of Gradle. So this has been one of the single biggest drivers for build happiness, for build reliability, is this project of what's in that upper left corner of the distribution, the spatial distribution of problems. Fix that, then fix the next one, and then the next one, and then the next one. And it's good to take a break as you're doing this exercise and congratulate yourself and pat yourself on the back for how far you've come. As particularly with that spatial view, it always takes up 100% until there's zero failures. So you could be making a lot of progress, but it might not feel that way. Which is why I've found it to be very impactful, very useful to continue to talk to my friends and peers about how they relate to the build and how they're doing and how they feel about it. Because that's what we're ultimately here for, to improve the lives and productivity of our coworkers. So a challenge we ran into in this kind of analysis is that not all failures are co-located with the cause of that failure, right? Our Gradle build is 300 projects and 6,000 tasks, and any task could potentially change some local state in a way that would mess up any other task, particularly if you were, hypothetically, not an expert of writing Gradle build logic when you first started converting an entire build from Anti-IV to Gradle, you might end up with some malformed tasks. And you might end up with failures that on this data source might show up as being in a test task when actually it was the setup task before it that didn't do its job but returned A-OK. And this is particularly problematic or challenging within the context of an incremental build, as incremental builds with some fraction of all total tasks running are simply less idempotent than a build where you run everything all the time, which would be obviously much too expensive in terms of your time, but the knowledge of what task is actually causing the problem does not show up in that viz I just showed you all on its own. And we found that this functionality to try and identify incorrect incrementalism was not built into Gradle or not built into build scans yet. And we found that we really needed it in order to wrangle the bugs and wrangle the complexity of such a large and complicated build. So we built what we call the IO-Detectorator, a detecting decorator that serializes build execution while instrumenting the file system, so we can then come back with an authoritative list of every file any task reads or writes from. And then we just ask Gradle, what are the declared inputs and outputs of this task? And if those lists don't line up, that is almost all of the time an incremental correctness issue and a bug waiting to happen, and particularly a nasty non-proximate cause bug waiting to happen. So let me show you what that viz looks like. Here we go. So because doing these Detectorator runs slows down the build, because you disable all incrementalism, you disable all parallelism, and then you slow things down further by instrumenting the file system, and a lot of file access goes on during a build like this, we kind of run it as periodically and on a one-off basis for investigations where we are led to suspect by the data that this might be an issue. And so, the way we have this set up, you can see that tab native API, gin constants Java happens to have undeclared reads of, Python, right? Because this task happens to invoke a Python script. And so this could be a potential bug, because you could say update the version of Python, and this task on some local developer machine might not rerun. And if changing the version of Python would happen to break something or not break something, then you can, then it's just an opportunity for a bug later on. So because of that, we know where to start. When something comes up where a task doesn't appear to be idempotent with respect to its inputs, this is the first place to look. And once the issues around here are corrected, then it gives you a lot more confidence that failures are proximate to their causes. And we relatedly check overlapping file I/O, and so that we can see when two tasks have contention over writing to a file for a very similar category of error analysis. I'd love to show you how this changed over time, but because of the one-off nature of how we run these scans, we don't have a nice temporal view for the Detectorator information. So the real takeaway I had from this, and the real takeaway I had from trying to optimize our build for performance to waste as little of people's time as possible, is that performance is always paid for in complexity, right? Parallelism and incrementalism are like completely essential for running our build in any reasonable amount of time. So not wasting, days and days building stuff that's already been built before. But incrementalism and parallelism both make debugging problems harder. And so if you want to enjoy those performance benefits, a level of rigor around measuring and dealing with their impact is essential for maintaining correctness in the face of performance. And so, like I said, the viz I just showed you doesn't rely on built-in features of build scans. That was a Gradle plugin and a way of doing CI that we ran ourselves. And so I'm curious, Hans, do you think that a deep scan feature, that opts you into paying a performance hit in exchange for deeper telemetry might be a built-in part of build scans in the future?
Yeah, so it's a good question with a clear answer, yes.
Cool.
Right, but at the same time, right, as you know, with all the flakiness issues, we still want to, make Gradle Enterprise so scalable and so efficient that most of the data is collected all the time. Because otherwise you get into the problems, I need to reproduce, right? And then enable this deeper data collection, right? There is data that will be so expensive, right, that you not can collect it for any build, but will be valuable. And then that would be, where you would have a CI build running every 24 hours to do some deeper sanity check. So absolutely. And then, of course, as you pointed out with that other item, strict mode, right? I think it points out to, in this case, too much flexibility on the Gradle side. So on the Gradle build tool side, you should be able to say, you know what, the build should fail if there's any overlapping output, right? So I think we will tackle that from two angles, right? And but the great thing is, right, that you were able to create your own solution, right?
Right. If the flexibility of Gradle's API and plugin model had not, other systems might not have allowed for that kind of introspection into the domain objects of the build at all.
No.
So the Gradle's flexibility made this possible. One request, if you do implement strict mode, as we saw in our viz of overlapping file I/O, we have a number of problems still to work out. So I hope when it becomes an option, we could enable it on a project level or on a subtree of the graph, so that we could turn on strict mode for everywhere that was compliant, and then work on the problematic areas one by one.
Yeah, so I would assume that it's anyhow something that you can configure down to a task instance level, right? So
that would be perfect.
Yeah.
That would be perfect. Well, thank you, Hans. So once you've worked out most of the core correctness issues in your build, you might notice something new happening. You might notice people complaining to you about the performance of the build. You might notice them saying that the build is slow. This might feel frustrating or demoralizing to you in your effort to build happiness, because you just put all that work into making the build as reliable as possible. But it's actually a good thing in a certain sense, because no one complains that the build is slow if it's horribly broken. So complaints about slowness can mean that it's better and more reliable than ever before. So, appreciate how far you've come in reaching this point, and then get to work trying to fix it. So your build is going to get slower without ongoing countervailing effort. People are going to keep adding more tests, keep adding more projects.
New frameworks, new languages, new compilers, new tool chains.
New forms of code generation, a new form of static
annotation
analysis.
processors.
And here again, Gradle Enterprise Data Analyzed with Tableau can help you to see and understand what the most important bottleneck in your build is. So let's just take a look at one of the performance visits that we use to keep an eye on how our incrementalism is doing. So one of the features that kind of comes for free with Gradle Enterprise, well, maybe not for free, it's a premium product, but one thing, we bought Gradle Enterprise specifically for the telemetry and analysis capabilities it was going to grant us. And so since that was what we wanted, one of the first things I set out to do was kind of try to quantify the impact of having that remote build cache just available turnkey on the lives of our developers. So, on the left here I put some common cacheable task types, that a Java developer is going to run into, check style, Java compilation, unit test execution, and I've tracked their cache hit rate over time, and this combines the local and remote cache. This data doesn't differentiate, and we make use of both forms of Gradle task output caching. And then I made an estimate of how much time this feature actually saves people by subtracting the average duration of a successful task from the duration of a cache hit, and then multiplying by the number of cache hits in order to guesstimate how much time the remote cache has saved a developer on a given week. And so here you can see that the impact of check style caching is relatively low, Java compile is pretty moderate, and the biggest impact in terms of time savings is actually on unit test execution, which is, I think comports with our intuition that test execution is one of the more expensive operations going on in a build. So combining all those together and showing all cacheable tasks, we estimate that the remote cache saves between 11 and, maybe like 12 and 8 hours a month per developer. So every developer in the organization over the course of a month saves hours because this feature is just there and available to them. I recall one period where I updated to a new Gradle version and I changed our initialization scripts. I completely disabled publishing new artifacts So the hit rate just gradually declined until we noticed there was a problem and went to go fix it. After that point, we started taking advantage of a feature of Tableau called data-driven alerting, where you can pick any given metric out of your workbook and say, send me an email when this drops below a particular value. And so in this case, we set the under 50% cache hit rate should get an email from us. So we've started, in this case, the changes we made that made the cache hit rate go down, we are gradually working to correct. You see that gentle slide upwards. The caching is just one small part of the performance story for a large Gradle build. All incrementality collectively is substantially more impactful. So here I've charted a variety of different lines. And the biggest one is up to date. This task has already been downloaded from the cache previously, or you built successfully, and so you don't need to do it again. And keeping this rate as high as possible is one of the biggest drivers for the build, just like feeling snappy and for feeling rapid and for keeping people in that state of flow as they work on their business problem rather than on build problems. And so with the similar methodology to the previous slide, I've estimated how much time incrementalism as a whole saves people who are building. So per developer per month, we're talking, between 30 and 55 hours saved. Now, that's pretty cool. That's a lot. This also points to some of the difficulty or the complexity of meaningful performance analysis, as because Gradle is so highly parallelizable, and we run it in such a highly parallelized mode, this is CPU time savings, right? This is not actual wall clock time savings. So if we go to the timeline view, which shows this kind of thing really well, you can see to the extent to which tasks are run on every thread, and so things do end up very highly parallelized. But we do have a few problems in terms of the existence of a long pole, which can substantially thwart your parallelization efforts. So the more parallelized your build is, the less saving CPU time. You have to consider what the speed up ratio is for you in practice in order to make a conversion between CPU time savings and actual wall clock time savings for the people we're trying to help here.
I'm curious, what we're seeing with our team that the machinery for CI is becoming a not irrelevant cost item for our company.
Yeah. Oh yeah, we've noticed that too.
So is that also something you analyze?
I have not personally attempted to analyze the business impact, as I focus more on the engineering side, but I think that would be really interesting.
Yeah.
In making a case to our organization to purchase Gradle Enterprise, definitely highlighted that this would and does save CI a lot of time.
Yeah.
CI is one of the best cases in terms of getting like a high hit rate, is we tend not to have local changes and builds overlap with each other substantially.
And it's two things, right? It's a time saving on CI, but it's also either things are faster or you need to you need to pay less for your CI resources, right?
Right. One trap that it's easy to fall into when attempting to analyze and attempting to maintain a highly performant build, if you don't have data like this, if you don't look at your Gradle build scans and see what the long pole task is you can put a lot of effort and put a lot of time and sweat into optimizing the performance of tasks or of build plugins that just don't matter if there's if there's one serialized execution that takes 10 minutes, nothing you can do anywhere else is going to make your build any faster than 10 minutes. So knowing when you're wasting your effort, when it's not worth doing something, so that is one of the key benefits of doing this kind of analysis.
What I see in organizations is, let's say, we're struggling with build performance, configuration time, execution time. We went in there, let's say, and improved the situation significantly, right? So, and then we came back 3 or 4 months later, and we said, well, significant regression. So, and for me, it's two things. On the one hand, have the high-level analytics to see, there is a problem, but then, if it's not easy to figure out the root cause, people will they will just surrender to it, right? So that is the two things you need. You need to really see some high-level analytics that say, in this area we have a problem, but then you also need to be able to deep dive into it to see what is the root cause for that. If one is missing of the both, right, you will not be effective. Right? That's my experience.
Absolutely, I completely agree. And what you say about regressions is spot on, right? Any reliability issues you fix, I mean, if builds tend towards entropy and chaos over time, and you need to make constant effort not only to realize gains, but to keep the gains you've made in terms of reliability or performance. I mean, you just have to be watching this data or periodically spending extensive effort on trying to, heroically correct the issue once and for all, only to have similar problems or categories of problems reoccur.
Yeah, but then you left a lot of money on the table for the 4 months, right?
Right.
That were of the latency until it was escalated that you had to do something about it.
Exactly, exactly. So trying to preempt that kind of thing through a good system of alerting and analysis is key. So we might have noticed this workgroup VQL web project coming up as our long pole, and as coming up as a big source of errors as well, if you recall the IO-Detectorator vids. This guy is so long and so error prone partially because Gradle doesn't actually build it. It just calls another build system that builds this very large and idiosyncratic from a language and from a tooling perspective project. And so we can't use, without converting its whole build to Gradle, which would be a massive undertaking, we can't use the tools that Gradle gives us in terms of having a task stack that's incremental and parallel and cacheable in order to substantially speed this up. But we don't want to just give up on what's causing us the most time and a substantial fraction of the errors. So part of our solution to this has become taking large or problematic projects, moving them into their own build, and consuming them only as binary artifacts, which we can have Gradle download and resolve like any other dependency. You can go even further with the most complicated areas of your build and the most complicated areas of your product, really, by trying to modularize it. A style of building and a style of organizing your software that has been exploding in popularity within Tableau. We still have effectively a large multi-project monolith for C++ and for Java and desktop and server. But since we added on the capability internally to do what is sometimes called maybe Netflix or Amazon style development of many modules that come together into independently shippable services or subcomponents, we have found a great deal of hunger for and a great deal of adoption internally on this style of development. And so if I pop over here, here's a little chart I have from my peer team that works on facilitating modular development. And this shows by what Gradle plugin is applied to a module, language adoption over time. And we can see that this has been incredibly popular right from the get-go when it comes to Java. And C++ and Python and TypeScript projects have also grown substantially. I will point out that this Java bar includes all JVM languages. It's just the way we did this analysis didn't notice that you applied the Java plugin and the Kotlin plugin, for example. So we are seeing increasing usage and internal popularity of Kotlin, which is my personal favorite language at the moment. So I've loved how Gradle is expanding the Kotlin DSLs. So yeah,
coming soon. Gradle 5.0 is.
I'm looking forward to it. And yeah, so you can see over only the course of a few months, we had thousands of projects created that use this style. And I largely attribute this phenomena that we were able to provide this capability to our developers to organize their software in modules if they so chose, to why our server build hasn't become a complete mess, right? A year ago when I gave a presentation at the Gradle conference, we had about 300 projects in the Java server monolith. And today we still have about 300 projects in the Java server monolith because a lot of the growth has gone here. Yeah. And that has really helped to keep the performance and the reliability characteristics trending the right direction without having to arbitrarily scale the size of our build team.
Are you doing any analytics kind of activity per project to show, okay, this is getting more legacy code, the change rate is reducing, so there's less need maybe for that part of the code base to modularize?
Yes, absolutely. That correlates very strongly with how many failures there are in an area. These things end up being very closely related. So you get something working and you just kind of leave it alone and until someone messes with it again, it generally kind of continues to work. The developers who have been able to work in this style have found, and we have analysis that shows this, and the workbook I just showed you merges information from Perforce and Gradle Enterprise and GitLab, our internal Git repository. And the developers who managed to work in this style for most of their work made commits to the code base about 3 times as often as those who work in the monolithic style, because having that more self-contained project to build means you have fewer dependencies, right? You have the same amount of binary dependencies, but fewer things that could mess you up in the moment. So this has been a very...
And the feedback cycle is faster.
Yeah.
Right?
Yeah.
So it's not just a matter, it's you have to pay a lower price for getting the feedback from the build.
Yeah, absolutely. Run rapid, it shortens the iteration time. It makes helps keep you in that state of flow when you're developing that way. as the human mind can really only handle so much complexity. No matter how intelligent you are, no matter how expert you are in your field, you can only keep so much in your head at once. And modular style of development is better at fitting code into a single human mind. So yeah, we've found this to be a key strategy for our ongoing journey to build happiness. The monolith is very much a push model for changes, right? You make a change in the code and it affects everywhere instantly, which gives you great consistency guarantees that if something works or is broken, it works or is broken everywhere. Modules make a trade-off in terms of consistency in order to adopt a pull model. No, I'm not taking your change in my service, and so you have to pass, my integration test. It has to be stable enough, and so it gives you more control over the things or services you own in exchange for possible inconsistency.
Yes, and that's how I see it, right? For me, continuous integration is a continuum, right? And what you basically what you're trading in, you get a little bit later integration. You have to pay attention that the version ranges do not completely, become unmanageable, right? But at the same time, you get more stability for the teams so that they can have a higher feature flow, right? So you trade continuous integration latency with higher feature flow. And I think people are able to model this now, right? Yeah. I think that's very important because everything in one repo doesn't scale above a certain organizational size, organizational structure. That's our experience.
Yeah, unless you're willing and able to make Google levels of investment in making a monolithic build.
But even then, you need the culture and the homogeneity of the engineering teams around that, right? So there's still a lot of organizational qualities you then also need to have. That I would say there's hardly a company in the world that has that.
Yeah, right? I would tend to agree. We're still trying to find internally the right balance for us, and I'm sure that right balance will continue to change and evolve over time of what is the most productive and effective way of organizing our software.
So I have one question here. So with the monolith, right, obviously everyone was complaining about build time, I'm sure, right? It was emotionally a strong pain for the developers. Now, in a multi-repo world, right, let's say the build is now 1 minute and 40 seconds, right?
Yep, at most.
They will not complain anymore. They're not saying, oh, it's way too long. But still, because you have now many more builds with many more repos, if you get it down to 1 minute, the business impact is tremendous, but it's no longer driven by cold data, right, and numbers, and not by developers knocking on your door, hey, we don't want to be in that situation. But so would you think that all the performance optimizations are as important and valuable from a business impact in a multi-repo environment compared to a mono-repo environment?
I think I would say that because of how Gradle's dependency resolution features work and how you guys have put a lot of work into making resolution of binary dependencies fast, performant, parallel, extremely reliable, that durations are kept down in modular context. Now, there's still challenges when you need to bring it all together into a functioning piece of software, right? Regardless of how you've organized your modules or your monoliths, when it comes time to run heavy-hitting integration tests, right? It's time to run the heavy-hitting integration tests.
Yep.
And so performance still matters. I think it might be accurate to say that pain or frustration is conserved. You just get to choose to allocate it differently to different people or at different times. And hopefully you allocate pain or frustration to the people who are domain experts, who are knowledgeable and motivated and own a particular area, who are then very equipped to deal with it. Whereas in a monolithic context, maybe my change breaks someone I've never met on the other side of the company's work and causes them a lot of hassle, and there's this long cycle time to bring it back to me so that I can undo the damage. Yeah. So, in our ongoing journey to build happiness, we've encountered a lot of challenges and we've learned a lot of lessons, and I think I can help you jumpstart your own journey by sharing some of them. So one challenge that's very relevant to analysis of this kind of data that doesn't come up as much in just interacting with the build as a user is the heterogeneity of builds. You can call it a build when you build a single project of that 300 projects DAG, or you can call it a build when you build every single one. It could be fully incremental, or it could be fully non-incremental, right? You could have to download dependencies, or they might already be there on your local hard drive. So we found it to be very difficult to compare builds to builds for a lot of our analysis because a build could be so very different from one another. So I either had to throw out a lot of builds in order to be only comparing, apples to apples, or focus on tasks over projects, right? So I mean, if you talk about like the number of, a task failure is a build failure, and if tasks are slow, then the build is slow. Tasks tend to be an actionable level of detail, right?
Yeah.
So we found that focusing on tasks over projects and focusing on tasks over builds was the right level from a debugging and from an optimizing perspective. And then again, this is only possible if the tasks are idempotent, if their problems are self-contained. So we were only able to achieve this because we had the IO-Detectorator or functionality like it in order to get the tasks in that good state.
So I want to add one more thing. Comparing builds, right, that includes trends even, right, is often, even if the same project, apples and oranges. So for us, on the roadmap for Gradle Enterprise, right, that is one of the things we want to provide, right? A build comparison that compares apples with apples and understands all those things. But because even when you do task level, right, you have an incremental compile task. One task, compiles 30 changes in the source file, the others 2, right? So that is high on our roadmap, right? To kind of filter that out, to give you real comparison, right? Because otherwise it is really hard to compare two builds, right?
Yeah.
But I think it's absolutely the right approach. Yeah. But even that sometimes is too coarse-grained.
Yeah.
As especially with incrementalism.
Yeah, absolutely. You can do some clever things with level of detail calculations or table calculations in Tableau in order to try and do things like establish an overall metric of incrementalism for a particular build, and then like bucketize into histograms, or similar like builds, and then you can filter by that set. So it's still possible to wrangle. It's just a lot of effort compared to just focus on the tasks.
Yes. Yep.
Another challenge, or a related challenge, is just the complexity of the domain. In 6,000 tasks, we've got at least half a dozen distinct forms of code generation, several programming languages, dependencies that cross a managed and native boundary, and it has been no replacement for expert knowledge of the different areas. You can have the chart, but if you don't have the knowledge of the specific areas of the build or the knowledge of the people who do have the knowledge, then it can be very hard to dig in a meaningful way, and you can be distracted by noise. So you need the expertise when working on a domain like this, both in how like Gradle's model of the build works. I mean, you're not going to get very far with Gradle stuff if you don't understand the difference between the configuration and the execution phase, and you're not going to get very far in applying it to your build if you don't know where the pieces of your build come from and how they relate to each other. I wanted and tried for a while to find like a simple metric for overall build health, right? Something where I could say to management or to my peers, like the build got 10% healthier because of this work we did. And I tried to do that for a long time, but I found that this metric, in my mind at least, needed to have several properties that I found to be difficult to realize, right? Like if people come in and build a lot more, like you might have seen on the chart of local failures, these spikes like this, is the build getting worse in a sine wave? No, those are just the work days of the week, right? People don't build as much on the weekends, so there aren't as many failures. So you'd want an overall metric of health to be insensitive to people just building more because they're busy, or building less. And you'd want it to be insensitive to whatever people know or developers know their own scenarios, so you'd want it to be insensitive to minor details of like what's a subset of the graph you're trying to build. I found that to be very difficult to come up with. I was not ultimately successful in coming up with, and hey, maybe one of you watching, if you figure this out, let me know how to come up with a really simple and sane metric for overall health. So instead of trying to come up with this, we focused on the failures, right? And even more importantly, we focused on the people. Because that's what we're here for. Like that's what I find personally gratifying about working on the build, right? If I fix a problem with the build, I fix a problem for my colleague Jill, or my friend Matt. It makes such a difference to the day and the lives of people who I know and care about personally and professionally.
So I have a question. So let's say the problems that I see is one of the friction that comes from between developers and the build engineers, the developer productivity people, right? It's like without the data, there's not much accountability. Let's say, for me, a funny example is a developer adds a new annotation processor, just purely the choice of the developers, right?
Yeah.
It extremely slows down the build.
Yeah.
And then they're complaining, well, the build engineers that the build gets slower, right?
Yeah.
And it's not by evil intent. They just couldn't connect the dots. So how do you deal with this kind of change management that developers make some choices, right, that affect the build time, but they're not aware of it? So how does it work?
Yeah, absolutely. So, as we're doing these kinds of performance analysis of either task execution or configuration time or whatever it may be, you can often track back a particular performance regression to a particular change. And you don't want to be in the business of telling your friends and colleagues, no, that tool that you, the expert, decided was just the right fit for your domain. I'm going to be the fun police and the productivity police until you know you can't use that valuable thing. But it does give you a starting point for a conversation, right?
Yep. So that they can kind of trade. I understand now the impact. Maybe it's not worth it, or maybe it's worth it.
Right.
So it's an organizational solution to the problem.
Yes, it can be an organizational solution to the problem, and everyone wants their build to be fast and reliable. So if you show them this annotation process or this plugin you brought in is problematic, then everyone's going to want to work with you on fixing that aspect of your shared experience. So you can, once you realize what the issue is, then you can talk about what to do about it and try and preserve the value they're getting from it with as little impact as possible. Constrain it to only applying that plugin during particular CI runs or on particular projects or putting something in a module. And so these strategies can help substantially. And the challenge is noise, right? CI environments are set up one way, developer environments can be set up any number of ways, and you want it to always just work. And that can be very, very challenging, both from an analysis point of view and from a bug fixing and a doing the work point of view, that builds are so different and build environments are so different from one another. I mean, it's convenient that Gradle Enterprise captures information like what operating system they're running on and some information about CPU resources, because when you see the performance got worse in your build, was it just because they were running 20 servers and daemon clusters and virtual machines on their computer? So the noise that you get from variety and configuration and variety of context that developers operate in is a continual battle, because this thing changes. It always changes over time. And so you can try and identify canonically supported scenarios and supported configurations. This helps you deal with the noise, but as we kind of saw in the, let me just tab back over to it. As we kind of saw in the reliability viz, one person who has some files locked, right, can cause a noticeable amount of failures all on their own, right? So as you try to pare down this ocean of information you're swimming in, you can make yourself susceptible to the other kind, the opposite, the inverse kind of noise problem. And if you identify some supported configurations or canonical scenarios, and those aren't what people actually use or what actually matter to people, you can put a lot of effort into working on things that just don't match up with the reality of how development is conducted at your organization. So I'd say there's absolutely no replacement for having relationships with your peer developers, and no replacement for their knowledge or for your knowledge, and trying to continually track how development actually happens rather than how you might imagine it to happen.
Are you using the data also to communicate internally? Is there something like a monthly build newsletter? This is what went well. This is where we have a regression.
Yeah, our engineering and services platform organization, definitely sends out that kind of information. It frequently includes graphs and charts and visualizations of this information, and this. And that's relevant to strategic decision making as well. This whole workbook is about the adoption of this modular way of doing things, and so you use this kind of information to make personnel allocations and budgeting decisions and strategic investment. You could say, look, developers are really into this. This matters to people. It's a big deal. Look at that growth rate. We need people on this or resources for this. And it's started to come up in one pagers and problem statements and in work billing that hey, this area is really problematic, and we can quantify how much. Right before we had this feeling that that work group VQOA project was a pain.
Yeah.
We could show exactly how much pain. We could say this accounts for 10 or 15% of all the errors experienced.
I'm just curious, did you ever do something like the Windows file system is slower, right, than Linux file systems? Did you ever do experiments with that, for example, how this affects the build time?
Linux is noticeably faster than Windows for running a build like this. Given that we have to support both, it didn't seem relevant to me except to be like cute, because like Tableau Desktop ships on Windows and Mac, and Tableau Server ships on Linux and Windows. Yeah. And so it has to work everywhere. It has to be good everywhere. And if I want to be like, I enjoy using Linux, look how much faster my build is than yours. You can, but it doesn't change the fact that at the end of the day it has to work well for everyone.
Yeah.
And then one of the biggest challenges is that you're never done. And I think this has been a recurring theme of this presentation, that if you want your developer experience to be world-class, you want it to be a competitive advantage relative to other shops in your industry, relative to your competitors, then you never get to stop doing this kind of thing. So long as the software is changing, so long as people are adding to it, they're going to keep slowing it down, and they're going to keep adding problems. And so if you want your developers to be as effective and as happy as they possibly can be, this is a continual investment. And you need to be receptive as someone working on the build to it changing, as the needs will change. That frustrating annotation process or static analysis tool that slows things down might gradually become just absolutely core to how the product operates. And so you need to be able to be flexible and accommodate that and find strategies. And the key to this is that this is a condition of life for everyone, whether you're deliberate about it or not. I mean, if you don't collect the telemetry, if you don't do the analysis, you're still going to march forward into the future. You're just going to do so blindly. You're going to be on a random walk of the possibility space of how your build and how your developer productivity might evolve. And if you randomly walk to build happiness, well, that's great, but it might not have been that likely. And so let's just briefly talk very quickly about how you can set this up for your organization. So obviously you need Gradle Enterprise. The data export APIs are only available on Gradle Enterprise. Are you guys going to add that to the hosted offering anytime soon, do you think? Data export API?
We're not sure yet when.
Fair enough.
Right, it will come, right? We work on the plan, so sometimes, I guess, next year.
Cool.
Right, so, yeah.
Yeah, so you need Gradle Enterprise, and then you need Tableau, obviously. And you can use a web data connector, which a colleague of mine worked on in a hackathon project that goes and talks to data export APIs, extracts the data you ask it to, and puts it in the columnar, fully denormalized format that Tableau tends to work with. And if this sets your computer on fire, I'm sorry, but not liable. So, use at your own risk. I will be watching this for, pull requests and such, and you're absolutely free to fork it and use it commercially or use it for however you like, and to adapt it to pick out the data from build scans that feels most relevant and most salient to you. And there's just the full Tableau documentation on the Web Data Connector APIs and interface available to look at as well. Alternatively, and I recommend the Web Data Connector option if you can get it to work, is GE Export, which is a little tool that Gradle helped work on with me early on in our investigation of this kind of project, which first dumps the data from the export APIs to Postgres, which Tableau knows how to talk to natively. And so this comes at the cost of having this intermediary server that you have to prop up. I mean, if you already have Tableau server perfectly willing and happy to store the data extract, you don't need an intermediary server, right? Or if you're only working on it on desktop, you don't need that intermediary server, you just need the extract. So this has added, the fact that we've used this as part of our ETL pipeline for so long has been useful, but did add a lot of hassle to keep it working, to keep the CI runs that performed this in good condition, and to have to prop up the machine and the resources to do it. So if you can avoid using this intermediary service, this intermediary database to do your analysis, I do recommend that. And that's all I have.
Awesome.
That's been my presentation.
Yeah, we have a couple of questions. There was an earlier question, how did you get the data from Gradle Enterprise into Tableau? Right, so that we just answered that.
Yeah. Feel free to clarify that. If my explanation of how to get it into Tableau was unclear, we can revisit that subject.
Maybe we just could mention the export API is a event-based API, yes. Right? So that is but for the purpose of getting into Tableau, right? The API is it's not optimized for that scenario, right? So So there's more you can do with the export API in terms of learning and just watching certain events.
Oh yeah, it's great to program against if you want to make like a cool little live service that's charting in real time.
Yes.
But for doing substantial amounts of analytics, that interface is not on its own the most conducive.
What kind of build culture, team culture do you feel is important to be successful with this kind of approach? How easy or hard is it to drive adoption or appreciation of this approach to the development team?
Absolutely. So for me, it was extremely easy. I can't promise that it will be for your organization, right? We work at a data visualization and analysis company, so if I'd said to someone, hey, we should use data to make better decisions, they'd be like, no, I don't want to. I'd have been like, you might not be the right fit for our organization. Right? So this is so at least within Tableau, everyone immediately recognized how valuable this was and how much we wanted to do this. And so yeah, that was an easy sell for us.
No.
I suppose I would say if people are resistant to fact or evidence-based investigation of the state of your build, or just believe that they know it so well already that there's nothing further analytics could add to their knowledge, well, like the proof is in the pudding, right? Yeah. Show them that you do this analysis. You can download a free trial of Tableau, you can download a free trial of Gradle Enterprise, and then do some of this analysis and ask them, hey, what are the top 10 reliability issues in the build? Yeah. And if their answer matches up with what the data actually tells you, that person is a valuable expert. Keep paying attention to them. But more than likely, it will not match up or not match up fully. I'm very confident that something will surprise even experts.
Yeah, we see this all the time.
Yeah.
Right. Oh, why this build takes 20 minutes, this Spring Boot microservice. Oh, someone worked from home and is using a VPN to a shared network drive, which is the build output directory. And we had that, and people were not aware that people were doing this, right? So, I mean, it's just, really? Garbage collection is 80% of that build time? And, it's just, you could tell so many, I'm sure, surprising stories that no one would expect, and we see this all over the place. So, good question here. Sam, where is your vision for what do you want to do next? How far do you think you can take this? Where do you see that you eventually want to take this capability?
Yeah, excellent question. Where does this go? So where I want to take it is ultimately the goal is to have the most productive, happiest development organization you possibly can. That's what I want, to track down reliability problems, track down performance problems, to track down any impediment between my friends and peers and doing their best possible work with the least possible hassle. So I foresee the kind of recursive problem-solving approach of fix the worst thing and then the next worst thing and the next worst thing forever as being an ongoing and winning strategy. Although, not winning strategy, you're never done, like I said. So you always keep focusing on it until such time as it's not an issue and no one's changing anything anymore.
Yes. And in the old days, that was the dream of the build engineers. It was, hey, we just want to have a stable build to ship stuff to operations.
We're going to finish it, and we'll ship software every 3 years.
And we don't care about what you want to do, right? So that was the culture in the old days, which frustrated developers to a huge degree, right? And and your service perspective, right? You're serving the developers, right? That is absolutely what we need. But we also need data for accountability, because I think the data is so important culturally to show, hey, we have an impact, we care, but also there are certain areas you're accountable for, right?
Absolutely.
Maybe you need to understand how to isolate your unit tests better, that they're not all hidden integration tests, which takes so long.
Which is a struggle we had and did go through. One thing I will add to the recursive problem solving and recursive performance analysis is that I want to be able to, a major goal is to be able to be flexible, right? When a new tool or new methodology comes out and people want to use it, I want to be able to facilitate that as much as possible. It would be such a shame for someone to come and say, hey, I love Kotlin, I want to use it in the project. Or, hey, we have this issue in this part of our native code, let's adopt Rust and its memory safety model. And you're like, that's really awkward, I'd have to go do work to support that. Could you just keep using the old tools just forever? So
Yes.
it'd be such a shame if it
Such
ever
a
came
shame.
to a point where I had to say that.
Yeah, but so there's still too many organizations where you have those discussions, right? And it's about it's work. Yeah, well, it's your job, right?
Yeah, right.
You know,
It's
those
work.
guys
You were going to be
make them
working on this
productive.
anyway.
Yes.
So
Yeah.
get it done.
Great. So one thing is a good question here, and I'm also curious about that. So has Gradle Enterprise been able, or the data, right, with what you're doing also with Tableau, of course, been able to establish some best practices for developers? So did some of the data inform them? Let's say you one example for that would be people don't do a pre-commit build, but you could see that from the build data. They do some builds with the dirty working copy, but then they just say, hey, see, I will figure it out, right?
Mm-hmm.
So things where you could say, hey, guys, you should do a build before you commit.
Okay.
Things like this.
Yeah, we actually implemented for that specific problem a gated check-in system where any change that goes in must pass a suite of unit tests, integration tests, and selected faster, even end-to-end tests, before it actually gets committed to the source repository. And that was huge for improving our overall build reliability.
And how do you implement that gate?
We made a little, so we use TeamCity for continuous integration, and we made a little web service that stages commits and kicks off
Got it.
the
Yep.
continuous integration runs, and if they look good, then it calls
Yep.
out to Perforce to actually submit.
So it's the delayed commit feature, right?
Exactly.
Yep. Got it.
Exactly.
Okay.
So that was very impactful. Can you remind me of the question again? I feel like I went off on
So
that.
how the data can help to establish a best practice standard, right, for developer teams? So did you learn anything about, best practices that could be improved amongst the developers, or was that never really the focus? Was it more like we need to get the machinery right, and that's our focus?
Definitely seen it as a facilitation thing. It's making it possible for people to do their best work with the flexibility and reliability they need. So I've rarely taken this data to try and directly influence product architecture as the needs of the product and the needs of the business are what should really dictate that. But the shape of the build, like the build is kind of a scaffolding for the software project you're working on, kind of naturally mirrors the shape of the thing you're building with it. So if you have something that's pathological about the build, it might also be something that's pathological about the build architecture. Like this big, complicated, error-prone chunk to build is very often also a big, complicated, and error-prone chunk to run.
Right.
And so this data can kind of help you see that. And it's not a perfect correlation or anything if you compare where your bugs come from to where your build problems come from. But there definitely can be overlap on that Venn diagram.
So two more questions from my side. Are you collecting, or would you like to collect data directly also from the IDE? And
Yes.
Yeah.
Yes, we would. I mean, developers spend a lot of their time in an IDE, right? And different people have different workflows and different relationships to their command line build.
Yes.
I mean, I've talked to some people who are kind of at extreme end of the spectrum, like, I don't care how fast the command line build is. Like, I load it up in IntelliJ, and IntelliJ builds it plenty fast. And then other people are like, yeah, I compile everything in the command line, as that's like the canonical representation, right? Like, that's everything that gets checked in. So I don't care. The IDE still has to be fast. I still live there, but I care a lot more about the command line performance.
So on the one hand, right, especially for the test execution, it's super valuable data, right? So, and what we see with larger repos, that the IDE is often the bottleneck itself, right?
Oh yeah.
Long re-indexing, memory problems. So I'm asking that with some egoistic kind of, because that's something we're planning also for Gradle Enterprise to collect data directly from
I'm
the IDE. So,
very glad to hear that. I mean, our build stretches Eclipse and IntelliJ to the seams, right?
Yeah.
And it's a frequent source of frustration amongst people. And IntelliJ starts re-indexing, and like, well, I'm done for 30 minutes. Like, I can't do any more work, and I don't have any insight into what it's doing or why that slows it down so much. I'm like, if I go to the command line, I can build the entire project in less time than the steps it's going to take. Like, what is it doing?
Yes.
And then I have to allocate more memory to it so that it can fit the entire representation of the build. So one thing I've been hoping might help with that, although it would require a certain amount of re-architecture of the build, is if I could partition the build into a set of smaller composites, then it would be possible to load up fewer at once.
Yes.
And limit the scope and resource
and
consumption.
that is also on the Gradle build tool side something we're working on with some of the new features. We don't have an out-of-the-box solution yet for that, but it's it's good to know that this is something where you see a lot of improvement opportunities.
Definitely a recurring pain point. It would be great if you could say to your IDE, I want to load up this project and all of its transitive dependencies, and that's it.
Yes.
Right?
Yeah.
So you're working on some subset of the whole graph.
Yeah.
You only need
Yeah.
your subset.
And with composite builds, we made a step in that direction, but it doesn't have this out-of-the-box thing, or we end up,
Right, you have to like re-architect the build to break it into composites,
Exactly.
and then you still might not have the granularity you want.
Yeah. So your TypeScript
Yes.
developers,
Yes.
what are you able, because what build system are they using for TypeScript?
So it'll be, so there's a mixture, there's a couple. They use Gulp, and Yarn is used for dependency management, and I think in some cases they are directly calling node commands to invoke Webpack and to invoke Yarn to do dependency resolution. And it kind of varies by project. Gulp, everyone was adopting Gulp for a while, and then it seems that they kind of put that to the side and went back to more raw NPM integration.
And is that something you do? You have custom solutions to collect data?
Yeah. So,
or is that or do you see now? We don't have the same level of insight, and we're paying a price for that because it's less stable than, let's say, the Java and the C++ builds?
Yeah, it definitely is. I mean, we have a Gradle plugin that wraps these projects, but it just invokes the tools native to that land, and it has been a recurring source of frustration that Yarn in particular is a little bit unreliable with how it performs, particularly in a context that it never expected to be run in, I don't think, of being in a large, highly parallelized build. We had to, at the Gradle level, serialize all Yarn invocations across the entire project, so we just never call it twice at the same time in order to keep it from corrupting its own caches. And hopefully it's gotten better since we had to take that measure. But the wrapping non-Gradle native build tools has had varying degrees of success. We've always gotten it working, but it also it does reduce its susceptibility to analysis, right? You get a black box if
the root cause effect is no longer there. Yeah, there is. You see, okay, there is some problem there, but it's
like if Gradle, if we're just shelling out to MS build or whatever else the case, whatever other CMake, whatever else the tool might be, then we're kind of right back where we were when we started for the server build, where we wanted to see not just that build failed, but what part.
Exactly.
So
and it is on our roadmap, right, to support, especially in the JavaScript area, right, to support the native tool chain.
Cool.
Right. So because that's just what JavaScript people want to do. You cannot force them. You shouldn't, right? It's the same thing. You shouldn't say, oh, you know what? You should use the Gradle JavaScript plugin, Gradle build tool. Well, no, we want to use those tools, right? So it's also then our approach with Gradle Enterprise. Well, then let's embrace that, right? And let's embrace that tool chain and provide the same level of insight that we provide for if you're using Gradle build tool natively.
Directly. We tend to wrap those other language projects with Gradle. So that developers who are working on the project can mostly build with their own native tools. And the build orchestration just happens to also call those tools via Gradle.
Yes. Cool. Awesome. Thank you so much. That was excellent.
Thanks, Hans.
Thanks
Pleasure
for coming.
to be here.
Awesome.
Hope everyone enjoyed my presentation and found it to be valuable. Thank you for your time.
Thank you. Bye.